Hey guys, in this video, we're just going to do some review of solving equations. So anytime you're asked to solve, it's always going to involve an equation or an equal sign. And our goal is to try and get one variable by itself equal to something. So we want to isolate w in this case. So what we're going to do is we are going to first simplify. Sorry, got a little fuzzy there. We're going to simplify each side of the equation first, and then we're going to get all the variables on one side together. So what we mean by simplify is get rid of parentheses and combine like terms. So I'm going to distribute this 3. So I've got 3w plus 21 minus 5w equals w plus 12. Okay, so now on the left side, I've got some like terms that I could put together. 3w minus 5w is negative 2w. I still have that plus 21. And I haven't done anything to this right side because there's really nothing I can simplify. So each side is now simplified as much as I can. So now I want to get my w's together. So another way to think about it is I want to get rid of the w's on one side of the equal sign. So I'm going to choose to get rid of these negative 2w by doing the opposite and adding 2w to each side. So I now have 21 equals 3w, because that's really a 1 there. 1w plus 2w, 3w plus 12. Okay, now that I have the variable all combined, I want to get rid of the 12 and the 3. We're going to get rid of the addition and subtraction first. So we're going to subtract 12 from each side, and let's see, we get 9 equals 3w. Lastly, to get rid of the 3, right now it's being multiplied by w, so we do the opposite and divide. 9 divided by 3 is 3, so we get 3 is equal to w. Remember, you can always check and see if you got the answer correct by taking this number and plugging it back in for w. If it is in fact the correct answer, when I simplify the left side, it should be equal to the right side with 3 in place of w. Okay, here we're going to do the same thing. So I'm going to distribute to simplify this left side. And that's all I can do on the left side. On the right side, I've got like terms. So negative 5x and 7x is 2x minus 12. I want to get my x's together. So I'm going to get rid of these 2x by subtracting 2x. Oh, and look, they're actually going to cancel on both sides. So here's what I'm left with. 12 equals negative 12. We know that that is not possible, right? 12 cannot equal negative 12. So whenever something like this happens that's not true, it's called a contradiction. And I just write no solutions when that happens. So basically what this means, when I get something like this that's not true, it basically means that no value of x will make the left side equal the right side. It's impossible. So that's why we say there's no solution. And it happens when we get something untrue. In this case, we had 12 equals negative 12. Here's another example. If I got 2 equals 5, that's something I know is not true. We can have the other instance, though, where I can actually have any value of x makes an equation true. And we call that infinitely many solutions. Or the kind of formal name for it is it's an identity. It's always true no matter what we put in for x. What that'll look like when you're solving, your x's will still cancel, but you'll be left with something that's true, like 0 equals 0. In this case, maybe I had been left with 12 equals 12. That is true. That would have been an infinitely many solutions scenario. Okay, literal equations. These are equations that consist of 2 or more variables, and we're going to be asked to solve for one of these variables. So we're not going to get it to equal a number. We're just going to get it by itself. So we're still going to use inverse operations and work backwards to get whatever variable we want by itself. You guys might recognize this from geometry. This is the equation for area of a trapezoid. We're trying to solve it for base 1. So I want to get rid of all this other stuff around base 1. So we're working backwards through order of operations. I always like to get rid of fractions first if I can. So fractions are really division, right? So this is being divided by 2. So I'm going to do the opposite, and I'm going to multiply both sides by 2. So dividing by 2, multiplying by 2 cancel. So I now have 2a equals base 1 plus base 2 times h. So when I'm solving, I typically go backwards through order of operations. So I'm going to undo this multiplication before I deal with the parentheses. So right now it's being multiplied by h. I'm going to divide both sides by h. So I have 2a over h. Right? I can't simplify because I don't really know what a and h are, equals and I don't really need the parentheses anymore because all I have left is base 1 plus base 2. I'm trying to get base 1 by itself, so lastly I got to get rid of base 2. It's being added, so we're going to subtract that from both sides. So here we have 2a divided by h minus base 2 equals base 1. So that's what we mean by solve for base 1. We got base 1 by itself. It's going to still be equal to an expression with variables. That's okay. We're just rearranging using inverse operations. Okay, next part of this lesson, you guys, is inequalities. Inequalities are something that uses something besides an equal sign. These are our 4 inequality symbols: less than, greater than, less than or equal to, greater than or equal to. And we solve them the exact same way that we do an equation. We try and isolate the variable. So here I'm going to get my variables together on both sides. So I'm going to, let's see, I'm going to do it this way. Yep, I'm going to subtract 13a, get rid of the a's over here. So I've got negative 5a minus 2 is greater than or equal to 8. I'm going to add 2 now. So I've got negative 5a is greater than or equal to 10. This is step to get rid of the negative 5. We're going to divide by negative 5. This is the only step here that is a little different than an equation. We are going to flip the inequality symbol. Anytime we multiply or divide by a negative, we're going to flip the inequality symbol. So this is still going to be or equal to, but now it's less than or equal to negative 2. Okay, and it says graph. So here is how we graph the solution. So up here you can see if it is less than or greater than, we use an open circle, and we use a closed circle if it's less than or equal to or greater than or equal to. So we're going to use a closed circle here. You don't really need any other values except for this one. So I'm just going to put negative 2 here. Okay, so I'm going to use a closed circle, and then I'm going to use an arrow to indicate which way my solutions are. So this says a is less than or equal to negative 2. All the values less than negative 2 are to the left, and the or equal to part is why we have the filled in circle. Okay, we're actually going to touch, this should actually just be a little bit of a review, you guys. This next part is probably new to most of you. Something called interval notation. So it's another way to list solutions when we have lots of solutions. So, right, there's an infinite number of solutions, numbers that are less than or equal to negative 1. So interval notation is just another way to write the solution set without using an inequality symbol. So we use parentheses to represent the open circle. It means that value is not included in the solutions. Brackets go with a closed circle, and that means that that value is part of the solutions. So in this problem, we always do left to right. So lowest value on the left, highest value on the right. So 5 is the lowest value. It has a parenthesis because it's an open circle. And then it goes forever to the right. So the number that we associate down like forever and ever is infinity. It's positive infinity on the right and negative on the left. This note down here says positive and negative infinity always have parentheses, not brackets. And the reason is because we can never actually hit infinity, right? Never actually get to it, so we can't include that value. Okay, the second one. My leftmost value or lowest value is 2. It's got an open circle, so it's going to have parentheses. 10 is the highest value, and it's a closed circle, so 10 is included in the solutions. Okay, this one goes forever to the left, so my lowest value is negative infinity. We always put the lowest or the leftmost value in first, and then it goes up to 5 and has a closed circle at 5. Okay, now this has kind of 2 different pieces, so I'll show you what we use here. We have, again, going to the left forever, so negative infinity, and it goes up to 3, but does not include 3. We use, this is called a union symbol. It's kind of saying I have solutions here or here. It's not possible to be less than 3 and greater than 6, so this is, or I'm going to write, sorry, I'm going to kind of draw here. So this means we say or, but it's called a union symbol. Okay, So it's saying we have solutions from negative infinity to 3 or from 6, oh, sorry, and that one should be a bracket because it's a closed circle, to positive infinity. Okay, last example we have is clearing fractions. I actually mentioned this in another problem that the first thing I like to do when I have fractions is get rid of them in a problem. Just makes your life a little bit easier. So LCD means least common denominator. So I'm going to actually think about these as fractions as well. Okay, so I'm looking at all of the denominators. What is the lowest number that they all go into evenly? So 3, 1, and 2, the LCD would be 6. Okay, so what we're going to do is we're going to multiply all parts of the equation by the LCD. So I'm going to show that kind of down here. So I've got 6 times 2/3 x minus 4 times 6. So I'm also multiplying that by 6. 6 times 1/2 x plus 6 times 6. So I literally multiplied every single part by 6. Now, when I multiply with fractions, right, this is really 6 over 1. Okay, so I've got 12, right, multiply straight across. So I've got 12 divided by 3 is 4. Negative 4 times 6 is negative 24. 6 times 1/2, again, if it helps to think about it as over 1. So I get 6 over 2, which is 3. And then 6 times 6 is 36. So as long as you're picking an LCD that everything goes into, it will always get rid of your fractions when you multiply everything by that LCD. The reason why that works is as long as you're multiplying the equation by the same thing, it's staying balanced. Just like when I add 2 to both sides, right now I multiplied both sides by 6. Everything by 6, it's going to still have the same value. I'm just changing how it looks. Okay, so now I'm going to get my x's together. I'm going to subtract, let's do this so we got to practice it one more time. Let's do subtract 4x. So I've got negative 24 is less than or equal to negative x plus 36. Subtract 36 from both sides. So I have, what do I got there? Negative 60 is less than or equal to negative x. This is really negative 1x, so I'm going to divide by negative 1. Flip the symbol, right? I'm dividing by a negative, so I get 60 is greater than or equal to x. Now, it's a lot easier to graph when we have the x on the left. So I'm going to actually write this as x is less than or equal to 60. So notice it's still opening up towards the 60, but now this makes it easier for me to graph the solution. So now 60, it's less than or equal to 60, so closed circle, solutions going to the left. All right, guys, that is everything for this video. Thanks for watching.